Just, okay.
Okay. Well, we're in the pilot house of the American Queen. This is where it really happens. This is where our pilots steer the boat up and down the rivers of America. The captain himself doesn't do his own steering, for he's in charge of every facet of the operation of the vessel. So he could be at any given moment downstairs in the engine room, taking care of needs down there, on the deck, taking care of needs there. The only time he's required to be up here in the pilot house is when we're coming into a landing, leaving a landing, going into a lock, or leaving a lock. Why then? Because the pilot can't see the sides of the boat from here, as you can see by looking out here. So the captain goes out on these bridge wings on either side of the pilot house, and those big white things out there that look like barbecue pits, they aren't. What they are is every control in this pilot house is mirrored out there, and the captain actually takes her into the lock, out of the locks, into the landings, and out of the landings with the controls out there. Then, once we're safely out here in the river navigating, the pilot takes over. Our pilots are full-time employees of the company, too, and to get their licenses, they got them back in the old days, like the river navigation charts you see here. They have to know these charts like the back of their hand, so much so that in their day they had to draw the charts within a tenth of a mile accurate from memory on graph paper, putting the sailing line in, all the buoys, the navigational aids, the bridges, their vertical and horizontal clearances, the locks, their locations, all that from memory to get their license. Today that isn't required. You have to make a certain amount of round trips to get your licensure, except if you're below the upper Baton Rouge Bridge down to the sea buoy. It is required down there to have pilotage, because down there you have vessels from all over the world. So it's a safety factor down there to have pilotage. So we don't have to take a pilot on anywhere, for we have full-time employee pilots, so we don't have regional pilots on board the boat. So that's the hierarchy of who's who. Now, the controls we have right here in front of us are what the pilot uses to steer the boat and to operate the boat up and down the river. For steering, unlike the old days where you had the big wheel that was mechanically linked down to the engine room to move the rudders of the boat, we have steering levers. That's what these two black levers are right here. They're connected under the console, so if you move one, the other one follows behind. I won't move them because that would put the boat into motion, and we don't want to do that. So if I were to move them, it sends an electrical signal down in the engine room. And down in the engine room on the back wall, you'll see two big hydraulic rams attached to our tiller bar. The tiller bar goes through the hull, connects to the forward two rudders, and then by cable, the back rudders are attached to that. So when you move these, it moves all four rudders together or in tandem. How the pilot knows that they've been moved right here is rudder angle degree indicator. There are two gauges right here in front of the pilot. The one over here on the starboard side is the rudder angle degree indicator, which tells him where his rudders are, what angle they've moved to, and he knows that his orders have been answered. If for some reason they don't respond, he looks at his steering control panel, the black panel over here with all the different colored buttons on it, and a light will illuminate to let him know what the failure on the system is. If it is that the pumps failed, all he has to do is flip this switch, for we have a backup set of pumps. We have the most precious cargo on the inland rivers, human life out here, so we don't want to run a risk of getting out there in the middle of the river and not having control of the vessel. So we have backups or redundancies for everything. If for some reason the hydraulic system were to completely fail and our pumps were to fail, we do have a backup for that. We have an electric non-follow-up rudder control where we can steer our rudders through this knob right here electrically to get the boat to the bank. That way we really, for all intents and purposes, have three complete steering systems here aboard the boat, so we shouldn't be able to be out here without the ability to steer the boat. How does he physically steer the boat? Standing between these levers, or sitting in this chair between the levers, he's looking forward at those two white king posts with the crowns you see up front there. And basically it's like taking a wheelbarrow down the driveway, because you aim the front of it where you want to go, and then you kind of walk around and shove it that way. Well, you're aiming that front end. And that's how you steer the boat. Just the same way as you see this toe going down past us here. He's steering from the back and pointing the front of his toe where he wants it to go. And if you're watching him there, you're going to notice here in a minute, he's starting to do it now, he's got a little bit of a slide going as he's lining her up to shoot down through that bend. So that's how you steer a boat up here on the river. How do we get up and down the river? How do we get against the current? Well, that big red paddle wheel is the real thing. It's not a Disneyland model or a fake. It really is powered by steam. Under our starboard stack right here, we have a single steam boiler that burns between 100 to 150 gallons per hour based on the service need. of number 2 marine grade diesel fuel and creates steam at 400 pounds per square inch of steam, 375 degrees Fahrenheit, goes back into our engine room to our 1932 built historic steam engines from the dredge Kennedy that ran on the Mississippi River until 1984. This boat was designed around those steam engines for her ability to run out here on the river. That said, how do we control it from here? Our engine order telegraph, this little panel right here. Yeah, I know in the old days there was the big brass stand, but ours is electronic. It's much easier. We don't have to move the handle, we push a button. And how that works, if I were to push the full steam ahead, notice there's a cover over it so I can't, but if I were to hit full steam ahead here, what would happen is a bell would ring downstairs in the engine room. When that bell rings, okay. When that bell rings down there, the engineer will come up to his panel that's just like that down in the engine room.
Turn that down too close.
You want me to hand you this one?
Yeah, you got to me.
Okay.
They're going to put you in jail.
So when he pushes this button, a bell rings in the engine room, and the engineer comes up to this panel. He sees what speed and direction we want to go. He then sets the engines in that speed and direction, hits his button that causes our light to light up right here in front of what we push. See, stop is lit up now. Full would light up there. And then, right here in front of the pilot, there's a gauge, the paddle wheel direction and revolution indicator, that tells him what speed the paddle wheel's going in what direction, so we know the order's been answered. Now that looks like there could be a lot of room for error there, if you will, and there is. So what we use is communication in case something goes wrong. Our steam engines, if we've been sitting here, like when we leave here at 1 o'clock, we've been sitting here for 5 hours, they're going to be cold. Well, cold compared to 375 degrees, so we can't put the steam straight in, and we don't want to run the risk of damaging the engines since they're historic. So before we get underway on every leg of the trip, we warm up the paddle wheel slowly and bring it up to service temperature. That said, if for some reason we couldn't get the paddle wheel going right now, the first thing we do is communicate with the engine room and see where they were in their process of getting the boat ready. We could do that with our radio, house phone, or voice-activated phone right here. This one, we can talk to 12 different stations on the boat by talking into this mouthpiece here. There's a metal baffle plate on the inside that vibrates, causing the electrical connection between 12 different locations on the vessel. So at no time would we not have communication with the engine room, deck crew, and various places on board the boat that we would need to, including the captain. So we have that ability. Well, what if we couldn't move right now? What if we had been sitting here for 5 hours, and let's say a boat's run out of control up here headed straight for us? What will we do? We have a trick up our sleeve for that. You see, when we built this boat, this is the largest single steamboat ever built for inland river service. 418 feet long, 95 feet wide. Compare that to the average steamboat of 150 feet long and 45 feet wide, and you've got an idea how big this boat is. So we had to make her more maneuverable. What we did was we added bow thrusters. That's what these two knobs are right here. Under the bow of this boat, at the point of the bow, there are two tunnels that go across that are 36 inches in diameter with reversible electric propellers inside of them. We can turn them on with these switches right here. Here are the stop switches, and we have a light to tell us whether they're ready to run and if they're running correctly, and we even have a gauge to see how fast they're going and what direction they're going. And we can change that direction here, and we can steer the bow at low speeds independent of the stern. Well, we obviously need stern thrusters too, and ours, that's the real trick up the sleeve, you see. Those are these controls right here, and the little screens on either side. What we have are azipods or azimuthing drives. Like a modern cruise ship has the big azimuthing drives that steer and are also their propulsion units. We have the same thing, albeit ours are much, much smaller because we don't have the luxury they do of all that space under the boat for water for these huge propellers. You go on a cruise ship and the propellers on their azipods are probably 36 feet tall. Ours are 4 feet tall. They're little tiny versions thereof. The beauty of them is this pod can be steered. It's basically a huge outboard motor, and it can be steered 360 degrees around. So any way we need to thrust this boat, we can. And we can augment the paddle wheel up to 30% if we need to get additional thrust. When you all have been playing downstairs, you may have noticed when we were on the lower Mississippi, occasionally you'd hear a high-pitched buzz the whole time you were playing, that the azipods were on. That's what that is. If we were coming up against current, you were hearing that the whole time you were playing. I'm used to it when I'm giving my talks down there. If I hear that, I can just tune it entirely out, and I'm sure you all have gotten to that point too. However, that's how you can tell they're on if you're down there, because you really can't feel it. You can't tell a difference. It's the same moving, but it can augment the wheel up to 30% if we need to. So that's the trick up our sleeve. If somebody came down here and lost control, that's how we'd move the boat real quick. Because we could get 3 to 4 miles an hour out of her if we needed to with them and safely get out of harm's way, because we'd know in enough time to be able to get her out of here. Let's knock on wood and hope. That said, that's how we get the boat up and down the river, how we steer. What's all this other stuff here? Aids to navigation, things to aid the pilot in doing their job. We have radar here. That's the 2 gray screens you see here. And radar came to the river after World War II. The beauty of this radar is, see, it's just a set of rudimentary dots and blips here, but what it shows the pilot is where the boat is. That's what this circle is here. That's us. We can see that boat that's going around the bend over there. See the blip right here? There he is. And we can see the curvature of the banks of the river. We can also see anything that's on the surface of the water, like a buoy. For that matter, it is so sensitive that a flock of geese would show up if they landed on the surface of the water. So if we're out here on a dark night far away from a town where there's no light and you can't see anything out here, I mean, really, when you're far away from a town on an overcast night, which tonight looks like it just might well be, it can be dark as the inside of a cow. There's nothing to be seen, so he can use the radar to safely navigate the boat. Also, if he needs light to see something, what if something lands there and a blip turns up where he doesn't expect it? Searchlight controls are right here. These 2 knobs right here, I can steer those 2 searchlights, which are out there in front of the fence on deck 5, around 180 degrees and 90 degrees up and down and illuminate anything we need to with a 12 million candle power beam of light, xenon bulb power, capable of transmitting a beam of light 7 miles clearly from this vessel. So we can pretty much see anything we need to see. We also have, right here, a global positioning system, or GPS. Now, a lot of people go, aha, that's it. He takes this little keyboard over here, says, I want to go to Henderson tomorrow, enter, and that's the end of that. If it was that easy, we'd have a lot of people back to Louisville wanting the pilot's job on here for it. It isn't. There are too many variables in river navigation for GPS to run a boat like you can do out in the ocean. Because there you have the luxury of miles of water for boats to safely pass each other that we don't have here. Plus, you also have all that great depth. I mean, with the exception of, the island of Genoa where the Costa Concordia was up on the rocks. It's pretty good out there in the ocean. But here, we don't have that. So what do we use our GPS for? Communication. Boats on the river below the Upper Baton Rouge Bridge all carry a transponder like an airplane. And a lot of boats up here on the Ohio River do too. Like the Angie Golding that went past us a moment ago. There she is. We're right here. And we can see she's going around that bend at 9.9 miles an hour. We see an arrow so we know what direction she's going. So we can use that for communication and also a reminder to the pilot of where they are. In addition, they have the ability to follow their speed here. They can put in waypoints, and as they're running, they have a real-time estimate of their arrival at any point they want. So we can use this for many different applications while he's underway. But communication is one of the main purposes of it, because we can now see who's out there and be able to contact them with our marine radios to arrange, that's the 2 black boxes right here, to arrange safe meeting and passing. Obviously, there has to be a rule of who has the right of way out here. Well, how this works is the downbound boat has the right of way. Why? Because he has to overcome the current to have water going past his rudders to steer. So we're downbound till the Mississippi, and then when we get there, we're going to be upbound. So on the way down, we can tell the upbound boat what side we want him to pass on, whether we want him on the port or the starboard. We can also tell him if we're coming into a tight bend, hey, you need to hold up below and give us room to come down. And then when we start up the Mississippi on our way to St. Louis, it totally reverses, and then he gets to tell us what to do. That is the downbound boat. So that's kind of how that works. One of the other reasons why this can't run us is our navigation channel. And the navigation channel I'll show you here on the charts. This is where the river is deep enough to navigate. That's what this dashed line is here, the sailing line. Why is it moving around? Well, the bottom of the river is very hilly, just like the top of the river is very curvy. And you will have an area, generally at the outside of the bend, where the current will naturally run and do natural excavation to keep you a navigation channel. Water's finding the path of least resistance. So it's going to go on the outside of that bend, which is why it's switching around here. So that's where the United States Army Corps of Engineers, who maintains the river, puts the navigation channel, wherever it's naturally going to take care of itself. And they dredge it down to 9 feet. For the most part, we have 15 to 20 feet in it, and it's generally only guaranteed to be 300 feet wide. So now you're starting to understand why we pass the way we do, because we don't have the luxury of space out here. So that's one of the things we have to take into consideration. Plus, this boat only has 8.5 feet down in the water, 62 feet to the top of the pilot house roof, and 99 feet to the top of the stacks. So she can be like a big sail out here, and the wind can start to slide her. So the pilot can see that slide in real time. He has things called swing meters, these black boxes on either side of the pilot that gyroscopically show him how much slide he has across the water. If she starts to slide too much to one direction or the next, you knock her the opposite direction with the steering lever, straighten her up, and come on up the river. And for depth, we don't use a sonar depth sounder, we use a fish finder. That's essentially what it is. It's right there, right in front of us. See the little black box there that says 16.5 feet? What that's doing is, from the bottom of the bow of the boat, which is 8.5 feet down, it's sending a signal down, bouncing it off the bottom, bringing it back up, and that's showing us the depth. So that we can see a sandbar, if it were to form out here on the river, sandbars build up progressively and then fall off progressively. If we were using sonar looking ahead, all we'd see is walls. The wall of the next bend of the river, the wall of a sandbar, something like that. This way we can see if the numbers start to come up, and the pilot will start to look for the safe way by watching the currents of the river to get around the underwater obstruction. They'll also note that on their bar book. Captain Schultz's bar book is right here, the green book, and they keep track of where they are and what the level of the river is, so he knows the next trip, if the river's up, he can safely get over it, and if it's down, he better steer around it. That said, that's our electronic stuff here, but what do we do for clearance under bridges or power lines? Well, you may have noticed our stacks move, and the controls are right here. They're hydraulic. We can flip these switches here, take the pins out that hold them up, and then bend our stacks down, and they'll lay in cradles on either side of the roof up here, so that at that point we're 62 feet tall. But we have bridges that we go under that are only 60 feet above the water, so how do we get under that? You're in an elevator. This room is on a hydraulic scissor jack and will lower right down into the superstructure. And when you're down there as the pilot, how do you steer the boat? Well, sometimes they'll go out on the bridge wing and do it from there. Of course, you'll have to duck, because the highest point of the boat then is going to be that handrail out there. That's 56 feet above the water's edge. So he's probably going to have to duck out there, or he can be down here in the rabbit hole and steer looking at the radar. That would be the two ways that they could do it to get us out of harm's way. The number one thing people love about this pilot house is right here, because you see, this being a steamboat, we can do one thing that diesel boats can't do, and that is blow a steam whistle. If I were to pull this handle right here, but I won't, it would blow that big steam whistle out there on the roof, and that is a signaling device. In the old days, that's how you told a boat what side to pass on. One whistle meant port, two meant starboard. One long and three shorts means we're backing up, operating under a stern propulsion. So the whistle is a signaling device, and it's really a backup for the radios. And because the steam whistle is right in front of the captain's face when we're pulling away from the landing, we also have a set of air horns back there on the roof, so we don't have to put steam and boiling water in the pilot's face or the captain's face to signal if we have to. And that's all backups or redundancies, if you will. We don't have to use it. A lot of the old-timers on the river love to hear the whistle, so we still blow it quite frequently out here on the river. That's my formal pilot house tour. Do you all have any questions?
Do these charts ever change?
Well, the charts are actually published by the